The square root property is the first method we're going to look at for solving quadratic equations. This should only be used on an equation that does not have a linear term, that is, an x term that is not squared or part of some squared expression. We'll look into why after we've gone through the process once. The first step is to isolate the squared expression. What that means is that we want our x squared, or it could be a longer expression like this x minus 6 squared, to be alone on one side of the equation. Once we have that alone on one side of the equation, we apply the square root property, which turns this into two equations, one using the positive square root and the other using the negative square root. So instead of x squared equals p, we would have x equals the positive square root of p, or x equals the negative square root of p. It's very important for us to remember to always include both the positive and negative square roots. Then we finish solving for x if necessary. So let's go ahead and try that on this example. Using the square root property, the first step would be to write this as x minus 6 equals the positive square root of 20, or x minus 6 equals the negative square root of 20. Now this gives me two equations that I need to solve for x, but my first step here is going to be to simplify the square root of 20 off to the side and replace it in both of these equations. Remember that we always want to take out perfect square factors if we have any, and 20 has 4 as a perfect square factor. So I'm going to break this apart as the square root of 4 times the square root of 5, which I would then write as 2 times the square root of 5, simply evaluating the square root of 4. So everywhere that I have a square root of 20, I'm going to rewrite it as 2 times the square root of 5. This doesn't have to be done at this stage. It can be done later instead. We're now on the third step, which is finish solving for x if necessary. We can see that these equations are not solved for x because they don't have x alone on one side. All we have to do is add that 6 to both sides in order to get it away from the x. In both cases, we are adding 6 to both sides, just using our basic linear equation techniques from way back when. That's going to make it leave from the left-hand side, so we have x equals. It's fairly standard to write the rational term first and the irrational term second, and part of the reason for that is that the quadratic formula will write numbers in this order as well. So I'm going to write this instead of 2 times the square root of 5 plus 6, I'm going to write it as 6 plus 2 times the square root of 5. And similarly over here, I'm going to write this as x equals positive 6 minus 2 times the square root of 5, so that I have two solutions to this equation, and I could write those using set notation if I wanted to as 6 plus 2 times the square root of 5, comma 6 minus 2 times the square root of 5. And then of course I would box my final answer. Before we conclude this subject, let's again take a look at this remark that we can only use this method if the equation has no linear term, that is, no x that's not squared. If we think about what we did in applying the square root property, we had a squared expression equal to a number. The only way that we were able to completely solve this for x is if we had only one x left in our equation after applying that square root principle. If we have both an x squared and an x term, there really is not a good way to adapt this to the equation unless we're willing to use the completing the square process first, which we're not going to go into in this particular exercise. So let's take a look at two equations and try to decide whether or not the square root property is appropriate for each of them. Is the square root property a good choice? Our first equation is x squared minus 5x plus 8 equals 0. This minus 5x is the linear term that we were referring to, so we could conclude that no, the square root property is not a good choice here. Even though it is possible to isolate x squared on one side, there will still be an x on the other side of the equation, and it's not going to allow us to completely solve for x using this method. The second example, x squared minus 18 equals 0, is a good choice because it does not have a linear term. There's no x there that's not squared or part of a squared expression. So this one we would simply start by isolating the squared expression, and we would do that by adding 18 to both sides. That would give us x squared equals 18. And then we would apply the square root property from here. X equals the square root of 18, or x equals negative square root of 18. Again, we have a radical that can be simplified in this example. So I would simplify the square root of 18 by taking out the perfect square factor, which in this case is 9. The square root of 18 is equal to the square root of 9 times the square root of 2, and the square root of 9 we know, of course, to be 3. So I would replace the square root of 18 with 3 times the square root of 2 in both instances, and then I would have my solution set. And of course, we always box our final answer.